Hey, sixth grade math team. Sorry we didn't have that practice. I successfully had my baby. We have a meet on Monday, and so this is kind of the best way I can think of going over these problems. What I'm going to do is post the paper copy of this, the next problem set, and kind of my answer key. So this is it. What I really suggest you do is try to work the problem yourself in some way, and then watch this video. Just especially if you're stuck, here's the way I kind of went through these to figure them out. Okay, so our first situation, Terrence has a huge pile of coins. So pause the video, try it out yourself, and then see if we get the same thing. Okay, Terrence has a huge pile of coins, pennies, nickels, and dimes. How many ways can he make change for 22 cents? So my thinking to make order of this is to kind of, you're doing a list and a table at the same time. So I'm gonna go like this. I'm gonna say dimes, nickels, pennies. I like to set up my lists big to small, or my tables big to small, and kind of use up one category until I'm out of it, and then I'll just kind of move it over. I really feel like they're gonna have a problem just like this Monday. So to make 22 cents, the first way to do it is to say 2 dimes, no nickels, and 2 pennies, right? 22. Okay, so that's way number 1. So way number 2 to me is if I reduce this one, I can't add any nickels right now, I'll go over. So I'm gonna drop my dimes by 1. And then right away, my first way to say what I'll do is I'll have 2 nickels and still 2 pennies. That's still 22 cents. And then I'm not going to change dimes. I'm going to come look at my nickels and say, all right, I'll just get rid of 1 nickel, and then I'll have, the pennies to kind of make up for that. So I have 7. Another 22. And then I'll say 1 dime, no nickels, and then I would need 12 pennies. And so the reason I set it up like this is because you just kind of see it flow down. Now I can't do any more of any coin. And so I have to say, all right, next category is no dimes, and kind of say, I'm going to reset back to this 20 cents and 2, 4 nickels and 2 pennies. And what I'll do each time is I'll say, all right, still 0. I'll take 1 away from you, but add that value here. So it'd be 7 again. 7 plus 15 is another 22. And then do that again. And I'll increase this time now to 12 again. And I shouldn't say final yet. Right? The most obvious one, I shouldn't say the most obvious one, but it's coming up. 1 and then 17 pennies. And don't forget, obviously, 0, no nickels, no dimes, and then 22 pennies. So as I count up how many of those different ways I just came up with, see, I kind of went from as many of these big units as I could. It's almost like hundreds, tens, and ones. But as many big ones as I could. Count down, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So your answer, you should say in the box, would be 9 ways. Okay, moving on to the next one. Rose is planting a garden for her backyard. And again, pause it, try it yourself before you check out my solution. 16 feet of fencing, so she draws a 5x3. If she drew a 5x3, you should draw a 5x3. Okay. And now that I have that, I'll keep going. Then around the outside, she surrounds it with 1 line of 6-inch square stones. Okay, so can you imagine a bunch of, this is big, she just surrounds it. She doesn't put them on the inside. I wouldn't be surprised if at the meet, maybe they mix it up. It'll either be out on the outside of this or the inside of this. But if it's on the outside, think about it. They're 6 inches each. So how many 6 inches can I get into 3 feet? Well, that would be 6, right? And I could do this and maybe make it, and it's going to be crude. They aren't going to be squares. They might, because I'm just great at this. But if I do that, 6, 12, 18, 24, 30, 36. So it's the same, inches to feet, right? So I just did 6 here. Well, if I had 6 squares here, I'll do the same on this side, 6. And the shortcut really is to just double your number. So if it was 5 feet, that would be 10 squares this way. So I can even just put a 10 here and then have a 10 here. Right, because they're each 6 inches, and these were feet. And this is 10 that are 6 inches each. As you notice, though, I did not completely surround it. I've got 6 and 6, which is 12, and I have 10 and 10, which is 20. So far I have 32. But I can't forget, I got to completely surround it. So that means 1, 2, 3, 4. And so 4 more, that gives us 36. So I would say 36 stones. Okay, so this is list table diagram, meaning you might do a diagram, you might do a list, or you might draw a table. Okay, on to the next one. In Euclid's house, there's a circular room with 5 doors. So again, pause it, try these yourself before you check out my solution. Make yourself a circle. Go ahead and do your best to make what look like 5 doors. Okay. And just read the problem carefully. How many ways are there to go in one door and then out the other? So just pick a door and say, all right, I'm going to come in through you and go out there. 1, do that. 2, 3, 4. So that's 4 ways right there. And you might have enough time. 6 minutes, you kind of got to go fast. But you'll see, okay, so that's 1. If I did it each time, well, how many of these are there? There are 5 doors. So you could draw the arrows again and get really confused, or you could say, well, if it's 4 for 1 and there are 5 of them, that's really a shortcut to say 4 times 5. So we're going to say there are 20 total ways to go in and out of the room. You can never go back out your own door, so that's 20 ways. Okay. The last one, not the last one, but this next one, 4. After reading this, and of course I previewed this, you see that there are 3 pets. And really the triple Venn, which seems hard to do, just kind of is the best way to do it. So we'll call these the A pets, the aardvarks, the B pets, the basilisks, and then the C pet, the capybara, whatever that is. So go slow with it, and as long as you fill this in and read it carefully, you're going to get the right answer. 6 have a basilisk and nothing else. Okay, 6 there. 2 have an aardvark and a basilisk. So A and B, that's 2. 4 have a basilisk and a capybara. I had to Google how to say that. 3 students have a capybara and an aardvark. And then 5 have all 3. Okay. 1 has none. So put a little 1 out there. And so it says there's 30 students total. How many kids have an aardvark? Now this is huge. At first I had the wrong answer because I didn't read this last bit. It says including those who have an aardvark and the others. Okay, so I say, all right, if it's 30, let me work backwards here. 30, losing the one who has no pet, I'm at 29. And then I'm going to list out these numbers and add them up. Oh, did I skip the capybara? I must have. Where is that? Where are you, capybara? I don't know. Where? Go back through. Okay, quick. 6 have a basilisk, nothing else. 2 have a capybara. Oh, there it is. 2 have a capybara. Okay, good. So now I'm going to say, all right, put these over here. 6. Oh, I'm sorry, guys. Jeez. I made my triple Venn. You may, you're like, what is he doing? 6, 2, 5, 4, 3, and 2. I just put those numbers here, and then I'm going to add them up. 8, 9, 5, 17, and then 17 and 5 is 22. So I have 29 who should fit in here, and I know 22 are already accounted for. So that's 7. You got to think carefully. Where does that 7 go? What does it really mean? Well, that's the number who have just the aardvark. All right, but the question again said how many have an aardvark, and it could include other things. So now you come back through and you say, all right, add these 4 numbers up. 7 and 3 is 10. 5 and 2 is 7. Combine those two, you have 17 kids. Okay? Next, 2 questions, and I found for these, I was winging it. I don't know I just know the answers like you guys. So what I did for this first one, again, pause it before you look at my solution. Susie's with her 4 friends. So what I did is I just made a list of it. I said, all right, S, 1, 2, 3, 4, and it says how many ways can they be in a line together? So what I'm going to do is figure out if Susie's in the front, and then I'm going to shortcut it at the end and just do, times 5, because there are 5 different ways to kind of mix them up. So what I did is I said, all right, let's just start at the end and mix them up like slowly, incrementally. So I got, obviously this is way number 1, and then I'll say S, 1, 2, and then just mix up the last ones. Okay. I'll kind of rewind back to my original and say, all right, now let's say S, and then 1, I'll mix these 2 up. 3, 2, 4. Well, if I have 1, 3, 2, 4, then I got to do S, 1, 3, 4, 2. I'm kind of seeing where 4 goes each time, you know. And then I'll say, all right, now let me just say S, 1, 4, and I want to always go like reset my remaining numbers back to being in order. It just helps me keep track. And then I'll say switch these last two. So S, 4, S1, 4, 3, 2. Now, because you only have 6 minutes, this is really where you need to stop. Because I think if you went through all of them, you'd start to see you're going to get the same pattern over and over again. So if you think about it, this is when Susie is in front and person number 1 is next. These are all the ways to mix that up. And there are 6 here. Okay? So then what I was thinking is, all right, well, if it's 6 this way, when 1 is in the front, that is in the second place, then what I'm going to do to fast cut it, instead of doing like S2 all those times, because I'll just get 6 again, and then S3 all those times, S4, I'm just going to say for this group, all the ways to do it with Susie in front, I'm going to say this number for Susie and 1, 6, times 4, because I would be putting these other people in those places. So 6 times 4 is 24. Now that's all the ways if Susie is in the front. But you know that if you then do this again, you would put Susie somewhere else in the sequence. And instead of doing all that again, I'll just say, well, if there are 5 possible ways to have somebody in front, I'm going to take that number and I'm going to multiply it by 5. And then when I do 24 times 5, I'm going to get 120. Okay, that was my technique. And so there are 120 ways to mix them up. You just don't have time to go through all of the actual ways. So you kind of pick the first 2, rearrange everything else, and then know that you're going to multiply once to say Susie's still in front, but somebody else is second, and then multiply by 5 because it's either Susie, person 1, 2, 3, or 4 in the very front with all these permutations. This one, though, I didn't see like a great shortcut, so what I did is say 1, 2, 3, 4, 5, 6, and I just started going by hand and said, all right, let me start off and say it's got to be increasing, so 1, 2, 3 is the most obvious, right? Boom, boom, boom. And the next one I thought was boom, 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 and then I'll do boom, 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 you know? So 1, 2, 4, 125, 126, okay? So now I've used 1 and 2, so I've got to only go up, so I'll say, I guess the difference is this one could have been any order. This one has a rule, so you got to follow that rule. So now I'll say boom, 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 boom. 1, and you'll see that amount reduce each time. So 134, 135, 136. I'm done with the 1-3 series. So now I'll look at the 1-4 series, which only has 2. 145, 146. And then my last one would be 156. So really, I can think about it this way. I'm done with 1. And when I did it over earlier, I said 156 over there, just kind of show that it's reducing. 4, 3, 2, 1. So I'm done with 1. So now I'll look at 2. And I feel like this one you do have enough time to do it this way, unless you know some algorithm shortcut. So now I'll say 234, 235, 236, 245, 246. And that's it for the 2 4s. My last one will be 256. And I'm done with 2 now because I can never reuse it again because I'm just left with these numbers. It's always got to ascend or increase. Next, I'll come to the 3, and I have very few to even try. 345, 346, and then I'll try 356, and that's it. I'm done. And my last one, even possible, is 456. I can't rearrange those because it's just 3 numbers left. And so what you do is you come back through, count up all the things you came up with. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you have 20, and then your unit would be numbers, I guess, 23-digit numbers. Okay, and our final one, the team round. This, you got to do your best with a picture, and then there's a little bit of a guessing moment. It's got this spaceship thing, and I'll show you the diagram that I put together. I basically made, these 2 fake planets are Tronzer and Awesome. So I'll say Tronzer, Awesome. And 6 minutes is, and with a lot of people thinking about it, don't try to do different pieces on this, but You have a spaceship here leaving every day, once a day. And it's saying, all right, when you leave Tronzer, how many spaceships from Ozum are you going to see? Okay, and so what I do is, it takes you 5 days to get there, so I'm going to mark out my days. I'm going to say, and this is how I do fifths. I don't know if you guys do it that same way. I'll say day 1, 2, 3, 4, 5. And I want to use something here to kind of help me. I'm going to draw these down. And if you have a problem like this, I think this is really going to help. Okay, and these are my days, because what I do, I don't know, everybody thinks about these things differently. This was the picture I came up with. So I know that a spaceship is right here and it's about to take off, okay? But spaceships have been coming the entire time. So what I'm going to do is say, when this guy starts, there's a spaceship, and I'm going to put a little arrow. Let's see, all the spaceships that are kind of here. There's one here, there must be one here, 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 and here. Okay, and there's even one here arriving just as my guy is departing. Okay, and so this is the guy who's going to leave Tronzer and go this way, and these are the shuttles coming from Ozum. All right, I think Spock is fake. We didn't need to know about Spock in this. Anyways, so Scotty is about to take off. All right, so the question is, how many spaceships is he going to see when he takes off? So what I'll do is go like this. I'm going to say he first comes right here, okay? And you'll see this start to make sense. So he's here, right? When he's here, think about it. It's in the middle of one of these runs. He takes off 10 a.m. There's a spaceship here. Well, they're going to meet each other right here. So what I'm actually going to do is take this spaceship now and go like this. Boom. Okay, and I'll do the same thing halfway here, making sure I'm stopping at halfways. Okay, does that make sense? It's like 10 p.m., you know, because it was 10 a.m., so this is 10 p.m. on one of the days. So it's asking how many spaceships is he going to see. So right now he sees this one, doesn't he? So I'm going to do this, and I'm going to just make sure I see that. So what I'll do now is I'm going to say, all right, next leg of his flight, he's going to come here. Well, once he gets there, think about all the other spaceships. One's going to come here. That one is going to be there. This one is going to be coming here. This one will be right there. This one will be here. And then we have another one that's about to take off. Okay, maybe I should have put it up there. I don't know. It's made sense to me. We're all different. So he intersects now with this one. He then goes the next half day, and this one here. And I mean, if you wanted to keep them on the same line and separate them, you know, you're free to do it however you want. But I don't know why this way seemed most trackable to me. So these guys are all now halfway through there. This guy was starting. He's going to be here halfway. He just took off. We meet another spaceship, okay? And he's going to come here. That guy will be there. This guy will come here. And the only way I could do this, I'm not even going to mark it there, but you see, so he's intersecting like basically 2 a day. 1, 2, 1, 2, 1, 2. So let's see. You'll see what my problem is here by the end. And maybe some of you already picked up on this. Just intersected another one. Now he's here. At that same time, this guy gets here. This guy gets here. There's another one who's going to go soon. We got another intersection. Remember, it's this guy and this guy. These guys are like previous flights that already passed. And here halfway, this one is now going to be right there. And then there's another one taking off. Okay. And then here, this guy is now there. And you're there. There's a spaceship that's about to take off, and he's getting close. He's got 12 more hours to go. This one will be right here. Another one takes off the C's. So he's seeing one each half day. And then finally he gets home. Now here's the problem with this setup, right? If I count my intersections here, the times that he saw somebody go by, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, the technical answer here is 11. And I've got different feelings about it. And I think what they're saying is that, like, right as he's about to go, right as he was about to go, what was happening? There was a spaceship that was arriving just at 10 a.m. And so we're saying, hey, he is going to see that one that's arriving, like, just as he leaves. Okay. And then when he gets there, he's going to see this brand new one that is just like departing at the exact same time. All right, so when you have a problem like this, I mean, I would try to diagram it your best way. This was the way that made sense to me. But we found that he was seeing a new spaceship each half day, even though the shuttles left on the day. Okay, so the official answer here is 11 shuttles. That's what he's going to see, 11 shuttles. Hopefully that makes sense and helps some people out. Again, I'll put another one of these up just for more practice. You guys are great. I'll see you Monday. I'll try to put a little post there about what to expect for a home meet. Things are slightly different since we don't have to go anywhere. Okay? Thanks, guys.